Hi guys. In this review we're going to have a look at some 2011 Chinese production 7.62x54R non-corrosive ammunition, and it comes in these crates of 1,000, and this is a very boring looking crate. There used to be some more markings on here, but it looks like somebody sanded them off. They were probably some sort of Chinese military markings, perhaps. So there's not a whole lot of marking on these crates. Usually military type crates have all kinds of interesting things on them, but this one did not. Very simple crate. It's got some cheap kind of a plywood top and bottom on it, and inside were two metal cans. We'll show you those in a minute, but I just thought I'd show you some of the paperwork that was inside here. Kind of interesting. We've got a slip here denoting the type of ammunition, the lot number, the contents, and who manufactured it. So I'm assuming this is the manufacturer of this ammunition. And there's a packing list here. I would assume this packing list must have been for the entire production run or shipment, because there's a crap load of ammunition in this lot number. Case number 1 of 10,000, unit quantity, total quantity, and the weight, total weight, the whole business. August 2011. So that's kind of interesting, because we're not used to seeing ammunition of this type that's that recently produced. So I'm not sure if this is just the entire production run of this lot number or what, but anyway, I sure as hell didn't get that much ammo. Anyway, we've got in the bottom of the crate here, kind of glued onto it, we've got instructions for 7.62x54mm ball cartridge, it says. And I guess, I don't know whether I'll bother reading through that, but you can probably pause your screen there and read through that if you so desire. But this is steel core with some lead in it, and it is non-corrosive steel case, and it is Berdan primed. So anyway, that's enough looking at the crate there. I'll show you what one of the ammo cans looks like. So typically for this kind of ammunition, it comes in the so-called spam can, and it comes with the key type opener, so you can get it open. And there is some marking on the top. We've got 7.62x54. You've got the lot number 31161, the cartridge type ball, and the quantity 500 rounds. So these open in the standard sort of spam can style. We've got the tab down here that you can pry up using the end of the opener, hook it through, and wind it back like you're opening a giant can of sardines. Now I've got one that I've already opened up, so we'll switch over to that one. Rather than bore everybody with a video of me opening it up. So once you've got the strip around the side peeled back, this actually broke off while I was opening it. Using this actually, that would be like that. It actually, the metal broke off right there when I was opening it. I had to use some pliers to get the rest of it off. But anyway, that's the opening strip taken off. Excuse me. So once you've got that peeled off, you can just take the top portion off. And inside there are 4 bundles. And as you can see, I've already removed one of the bundles. And the bundles each contain 125 rounds of ammunition, and you can see it's all put in there fairly neatly. There are paper strips inside to separate the rounds, and it appears that this is ammunition which was intended for machine gun use, because it's in packages of 125. So 2 of these packages would load a belt of 250 rounds. That is my assumption on that. Someone will no doubt correct me if I'm wrong, But anyway, it's packed in a fairly bulk type of package, not in boxes like you would get if it were intended for rifle use or anything similar. So you've got your 4 packages per tin. I'll just put that back in there. I'm going to have to find some ammo cans to store this in, because this is really not the best way to store this once you've broken it open. And we'll have a look at some of the loose ammunition. I just threw some in a plastic box for taking to the range. And here is what the individual rounds look like themselves. So it's a copper-plated steel case, a copper-plated steel jacket, and it is of course Berdan primed. See if we can get you a good close-up look at the head stamp. So it is 61/11. So I'm going to make the assumption that 61 is that company's production number or factory number, and this is production from 2011. So we're going to pull some of this stuff apart and have a look at what's inside it, and later on I'm going to show you some footage. I don't know if it'll be in this video or in another one, but I've actually done some shooting with this stuff already, and I'll show you some velocity readings and some accuracy tests that I did in my 9130 sniper rifle. So I'm going to break a few of these rounds down so we can see what's inside them. Alright, I've pulled apart 10 rounds of this ammunition, and the first thing we're going to have a look at is the bullet itself. As you can see, this is a full metal jacket boat tail design, and it has a cantilever impressed into it here for the cartridge case to be crimped into. And this is a steel jacketed bullet with a copper wash. And I think the copper kind of has 2 functions in this style of a bullet. The copper tends to provide a slight rust-proofing feature, and it also is slightly more slick or lubricating than steel to steel would be. Putting a steel bullet down a steel barrel would tend to gall, so I think the dissimilar metals provide some degree of lubrication or anti-galling effect. You can see this black substance on the bullet here. That's tar or asphalt, which was applied to the inside of the case next to waterproof them, being as this is a military spec loading. One thing that is apparent when you look at several of these bullets, kind of line them up and look at a bunch of them, is that the bases are not terribly regular, and that is it kind of shows up on target. Usually the quality of a bullet's base is just about the biggest factor in its accuracy or lack thereof. You can see these 3 bullets look, the bases look quite a bit different from bullet to bullet. These are a steel core bullet as well, and I took the time and effort to actually section one of these and sort of take a quarter of a section out of it. And hopefully the interior construction is apparent. This is just cut a couple of directions with a Dremel tool, but you can see the exterior portion of the jacket here, and you can see inside the steel core in the center. There's a lead sandwich between the steel jacket and the steel core. That lead piece in between, and the lead also goes up to the tip as well. And sometimes on some of these bullets the lead squishes out around the back of the core, and some of them it doesn't. Now I've got a few of the pieces that I cut off when I was sectioning that, and this sort of shows the sort of the sandwich effect a little better. This is the exterior jacket. You can see the copper plating on that. There's the rest of the steel, which is quite shiny here, and then we've got this piece of lead in between, which I just pulled off there. Like I said, that lead is sort of sandwiched between the bullet jacket and the core. And here's a piece of the core that I cut out with the Dremel tool, and it's a mild steel or iron core. And this is not an armor-piercing style of ammunition. The steel is basically very mild, and it is done for purposes of economy, because steel is a much cheaper commodity than lead is. So for the large quantities of ammunition that militaries use, the savings is quite significant in raw materials. So I've taken one of the bullets, and I've taken the tar off it there, or the asphalt off it, and we'll just measure that up to see the diameter of the bullet itself. So there we've got .311, so no surprise there at all. That's a very standard and expected dimension to have for 7.62 by 54R. And because this is a steel core bullet and it's a boat tail, it is fairly long for its caliber and its weight. So we've got a bullet that's 1.265 inches in length. That's a fairly long bullet. If that was a lead core bullet, it would probably have to weigh about 180 grains to be that long. But because it's steel core, it's only about 150 grains. So having mentioned the weight, I'm going to go grab my my cheat sheet here, and we'll have a look through the weights that I got when I weighed all these bullets out. So here is the data that I collected from pulling apart and weighing the bullets. Pulled apart 10 rounds, as I mentioned. There you can see the range of bullet weights that I got over the 10 rounds. The lightest weight projectile was 148.7, and the heaviest was 151, which gives us a very large extreme spread of 2.3 grains. The average was 149.8, so we might as well round this off and just call this 150 grain bullets. And we got a standard deviation of 0.78 of a grain. So that's not exactly what you call match grade by any means, but keeping in mind that according to the packaging, this ammunition was intended for machine gun use. So I'm sure it would have met the specification for machine gun use, because with machine guns, dispersion is actually considered to be something of an asset. It gives a bigger beaten zone and so forth. But for us civilians who are shooting this out of bolt-action rifles and SVT-40 semi-autos and so forth, that is a bit of a negative thing for us. However, this is economically priced ammunition, so there's only so much you can expect considering the price point. Alright, the next thing we're going to have a look at is the powder charge that's in this ammunition. Once again, we pulled apart the 10 rounds, so we'll just dump a charge into the scale pan there to have a look at it. And as you can see, it's a kind of a medium gray color. It's an IMR style of stick powder or extruded powder. And it must be of moderately fast burning speed for that style of powder. I would have to guess it's somewhere around a IMR 3031 thereabouts, based upon the velocities and the charge weights. So as I mentioned, I pulled 10 of those apart. Here are the charge weights, and they varied from a low of 43.3 to a high of 44, which gave us an extreme spread of 0.7 of a grain, which is actually a fairly large extreme spread for modern production ammunition. We got an average of 43.7 grains over these 10, with a standard deviation of 1/4 of a grain. So, once again, it's got a bit of variance to it. However, it is a military style of ammunition, and it was apparently loaded for machine gun use, so no surprise that it wasn't loaded to the most uniform of standards. Okay, let's have a look at the final component of the ammunition that we're going to examine today, and that is the cartridge case. Now, this is steel-cased ammunition, and the steel has been coated or plated, electroplated with copper, and the copper is there mostly to provide some degree of corrosion resistance, although you don't want to test that too much, because you leave this stuff on the ground overnight after it's been fired and you will probably see rust on it the next day. So the copper does have some advantages over lacquer coating, which some steel-cased ammunition uses, because the copper will not come off the case itself and give you extraction problems, which can often happen with lacquer-coated steel cases. They can give you some grief. This shouldn't cause those issues, especially in self-loading firearms where there will be some heat buildup, and even in the Mosin-Nagant where sometimes you get some sticky extraction problems. That shouldn't be an issue with this particular ammunition. So we'll have a look here at the case head itself, and it is number 61/11, 61 presumably being the factory code, and we know this is 2011 production based upon the documentation that was in the crate itself. So we've got a little bit of asphalt on the inside of the case neck. You can see that black line in there. That's asphalt or tar, designed to provide a waterproof junction between the cartridge case and the bullet. And if we have a look down inside there, we can see, if the camera will focus for us, come on, focus, we can see the two holes looking back at us, which indicate that this is a Berdan primed case. Of course, like all Com Block 7.62x54R ammunition, this is Berdan primed. However, it is non-corrosively primed, and that's the big selling feature for this ammunition. That and the fact that it is of fairly current production, 2011, this being 2014. It's unusual to see this type of ammunition that is that fresh. We are used to seeing stuff which is 30 and 40 odd years old. So you can see the copper coating on this steel case goes all the way down inside. I have not bothered to try to remove one of the primers. I expect it would be a very standard looking Berdan primer. Interestingly though, it is a smaller sized Berdan primer. It is a .215 or 217. It's kind of hard to measure it without taking it out of the case. But on the left hand side here we've got some Chinese military 7.62x54R ammo, some older stuff from 1968, and you can see the difference in the primer size. This stuff on the left, the old stuff, uses a .250 inch primer, the old style, old size of primer, and apparently the Chinese have switched over to using a smaller size of primer for their newer ammunition. That might be sort of a standardizing thing, because they probably use that size of primer for some of their other small arms ammunition as well. So nothing terribly exciting about the cartridge case itself, but I think we're done looking at this for a benchtop review, and I think I will do a video number 2 where I will do some show the results of some shooting with this ammunition, and then you can see for yourself the chronograph readings and some accuracy testing. So thanks for watching, guys. We'll talk to you in the next video.